No, you didn't misclick. No, this isn't a lecture on the topic of ornithology. This is actually a lecture on the normal distribution, parametric distributions, and non-parametric distribution types. And this I find to be the easiest way to at least visualize the concept. And I call this the Avian test. So we're just going to walk through this a bit. And again, this is not a meant to be a trolling or anything like that, but it's just a way, again, of sort of conceptually understanding what is going on when we talk about the normal distribution, the parametric distribution, and non-parametric data. Okay? So bear with me here, and I promise you by the end of this particular video, which will be a short one, you will have a greater understanding of the concept. So what is this here? What is this here that is pictured on this particular slide? Well, this here is a swan. So swans obviously have various attributes. They have wings, they have feathers, they have webbed feet, they have beaks, they have a certain swivel neck type, they have a pronounced tail, they make a certain call, they live by bodies of water, etc. There are many other attributes of the swan, but for the sake of this particular lecture, those are all the attributes that we'll cover. Again, this is not a lecture on avian variety itself, but more to draw a distinction between different statistical concepts. However, if you understand what a swan is, and in your mind you can define a swan by its varying attributes, if you were to see, say, this next slide, you could probably draw distinction and make conclusions as it relates to this next bit of avian variety here. So remember, this is a swan, and we'll pretend that you've never seen the next bird ever in your life, okay? So this here is a Canadian goose. It's not a swan, but by looking at it, you would understand, having never seen it before, that perhaps that it shares similar attributes to a swan. It also has webbed feet. It also has tail feathers. It also has wings. It appears that it can fly. You would expect to find it inhabiting a space near a body of water. It has a beak. It probably has a call similar to that of the swan. It has a swivel neck. So think of the swan as a normal distribution. Okay, it's a textbook definition of the normal distribution. If you were to open up a book on various creatures in the New World, etc., you might see this picture and you would know what a swan is and you would know what the attributes of a swan are. Which means that if you were to encounter a Canadian goose or some other bird which was similar, you could, without seeing this particular bird interact or move about, you probably would be able to make certain summaries about its behavior just based on your understanding of the swan. So again, it's not a swan, but it's similar to a swan. So perhaps certain attributes of the swan also apply to the goose. So this would be normal distribution, a perfect normal distribution, which only occurs typically in textbooks and within the definition itself. And this would be our parametric distribution. This is data which adheres enough, close enough to the normal distribution that we can draw certain inferences that can be made as it relates to the normal distribution. For example, the Chebyshev's theorem, some of the other attributes, we might be able to infer, or at least close enough, infer certain things about our data. So if our data appears to be close enough to a normal distribution, we run a Shapiro-Wilk and we find out that the data is parametrically distributed, well, then we can make certain assumptions, certain similar assumptions that are true for the normal distribution. Again, they're not going to be 100% true. Obviously, the swan is white. This is brown and black and gray. The swan has a certain call, the goose has a certain call, the swan is a certain size, the goose is a different size. But there are enough similarities that we can start to draw conclusions. Now, let's say that we're working with continuous data, okay? Because as it relates to the normal distribution and parametric distribution, it's continuous data. All right, it's a continuous variable. And let's say we encounter this next creature here. Well, there's something going on here. This looks to be a bird of some sort. It has a beak. It has some kind of feathers. Maybe there's wings somewhere over here. It's got feet. They don't look like they're webbed, but probably from what we understand about the normal distribution, we'd be able to infer that this is a bird of some sort, but with different characteristics than that of the normal distribution and that of the parametric distribution for that matter. So this, if we were to run a Shapiro-Wilk test on our data, and we found that our continuous observations were not adhering to a parametric distribution, but we still wanted to run tests on that data, we still wanted to assess that data, we would have to run non-parametric assessments. So again, we'd be operating under the assumption that the data is still somewhat normally distributed. It's still kind of a normal distribution, but it doesn't adhere enough where similar assumptions could be made. So this is our normal distribution, textbook definition, all right, doesn't really occur in the outside world, outside the textbook, outside the classroom. This is parametric data. It's data which adheres to the parametric distribution definitions. We can apply methodologies to it. It's continuous observations. And we can draw certain inference, certain attributes that are similar to that of the normal distribution. But it's close, but not cigar. It's close enough. This is our non-parametric data. This is data which is still continuous. It's still somewhat normally distributed. It doesn't adhere to the Shapiro-Wilk. Shapiro-Wilk says this is non-parametric data. So this would be our non-parametric data, which is still somewhat bell-shaped, but we would have to use non-parametric alternative tests. So a couple, generally speaking, attributes apply as it relates to the normal distribution, but not enough that we'd be able to use parametric tests. We'd have to use non-parametric tests. So one more time from the top, and then we're going to call it a day as it relates to this silly lecture here. Normal distribution, only in classrooms, only in textbooks, okay? Parametric data, close enough to the normal distribution that certain attributes apply. Non-parametric data, still somewhat related to the normal distribution. We can still run tests which are similar to parametric tests on it, but we have to run the non-parametric alternatives because it's just too funky to apply the similar attributes of the parametric assumption to this data. Hope that this helped. I know we went a bit off the beaten path, but I find that this description is a tried and true, and I'm trying to explain this topic to newcomers to the field. If this did help you, please consider liking and subscribing. It would mean a lot. And check out some of the playlists. They're there to help you out. You made it to the end. I appreciate it. And I hope you have a wonderful rest of the day. Take care.